Look up at the night sky, and what do you see? A scattering of stars, maybe the faint glow of the Milky Way stretching like a river of light across the darkness. But here's the thing, what we can see is just the tiniest glimpse of our galaxy's true nature. The Milky Way isn't just a collection of familiar stars and planets. It's a cosmic treasure chest filled with objects so bizarre, so utterly strange, they seem to defy the very laws of physics as we understand them. We're talking about celestial phenomena that leave even the most brilliant astronomers scratching their heads, mysteries hidden in plain sight, waiting to unravel the secrets of the universe. Imagine a star so dense, a single spoonful of it would weigh as much as a mountain, or a cloud of alcohol so vast it could fuel 1 trillion interstellar parties. These aren't science fiction, they're real, they're out there, and they're just the beginning. From rogue planets drifting alone through the void to black holes spinning at impossible speeds, the Milky Way is home to wonders that challenge everything we think we know about space. And today, we're diving into 30 of the most mind-bending, reality-warping objects ever discovered in our galactic backyard. This isn't just a tour of strange cosmic oddities, it's a journey into the unknown, a chance to explore the edges of human knowledge. Every one of these objects tells a story, a puzzle piece in the grand mystery of how our galaxy works. Some might hold the key to understanding dark matter. Others could rewrite the rules of star formation, and a few, well, we still have no idea what they actually are. So buckle up, because by the time we're done, you'll never look at the night sky the same way again. The Milky Way is weirder, wilder, and more wonderful than you ever imagined, and we're just getting started. Somewhere beyond the Milky Way, hidden in the darkness between galaxies, there's a force so powerful it's dragging entire star systems toward it, including our own. Astronomers call it the Great Attractor, and it's one of the most perplexing mysteries in modern cosmology. Picture a cosmic whirlpool, an invisible hand tugging at thousands of galaxies across space. We can't see it directly, but its presence is undeniable. Every galaxy in our local supercluster, including the Milky Way, is racing toward this gravitational behemoth at over 2 million kilometers per hour. What makes the Great Attractor so strange isn't just its immense pull, it's what we don't know about it. Nestled about 150 million light-years away, behind the thick dust clouds of our own galaxy's plane, this region glows faintly in X-rays, hinting at clusters of galaxies bound together by something far heavier than visible matter. But when scientists tally up the mass they can observe, stars, gas, galaxies, it doesn't come close to explaining the gravitational grip this anomaly has on the cosmos. That means most of its mass must be missing. This is where dark matter enters the story. The Great Attractor challenges everything we think we understand about how the universe structures itself. If invisible matter isn't warping space-time here, what is? Some theories suggest it's a supercluster of galaxies so dense, its gravity ripples across intergalactic space. Others speculate it could be a cosmic junction, a place where multiple filamentary threads of dark matter intersect, amplifying gravity in ways we've never seen. And then there's the unsettling possibility that the Great Attractor isn't the final destination. Recent studies hint that something even larger, a structure nicknamed the Shapley supercluster, might be pulling it like a chain of celestial dominoes. The deeper we look, the more the universe reveals itself as a web of invisible forces, rewriting the rules as we go. The Great Attractor isn't just dragging galaxies, it's pulling our understanding of physics into uncharted territory. But while the Great Attractor tugs at galaxies from the shadows, there's another cosmic oddity that stares back at us with eerie perfection: Hoag's object. This isn't your average galaxy. Picture a brilliant golden core glowing like a cosmic ember, encircled by a flawless ring of young blue stars so symmetrical it looks crafted by some celestial architect. Stretching 120,000 light-years across wider than our own Milky Way, this ringed wonder floats in isolation, a puzzle suspended in the void. Most galaxies spiral or clump in chaotic splendor, their shapes forged by collisions and gravity's messy dance. Hoag's object defies all that. Its pristine ring forms a near-perfect circle, with a gap so pronounced between core and ring that astronomers initially thought they were seeing two galaxies superimposed. But no, this is a single, freakishly harmonious structure, a galactic bullseye that shouldn't exist under conventional formation theories. So how did this cosmic donut come to be? One leading theory points to a violent past, a smaller galaxy piercing through a larger 1 billion of years ago, sending shockwaves that triggered star formation in a rippling ring. It's like tossing a pebble into a pond, except here, the ripples ignite new stars in a shimmering circle. Yet there's a problem: no visible debris, no telltale scars of such a collision. Others propose a slower process where gravitational instabilities gradually sculpted the ring, but even that fails to explain its uncanny symmetry. And then there's the isolation. Hoag's object floats alone with no neighboring galaxies to disturb it. Most ring galaxies are entangled in cosmic traffic, their shapes twisted by nearby forces. This one exists in serene solitude, as if the universe placed it under glass. That solitude deepens the mystery. Without external triggers, what sparked its perfect form? Even stranger, Hubble images reveal another faint ring galaxy lurking in the distance behind Hoag's object, as if the cosmos is teasing us with a matching set. Are these rare structures connected by some unseen rule, or is it just a playful coincidence? Every answer raises new questions, and Hoag's object remains a glittering enigma, a reminder that the universe holds beauty we can't yet explain. If Hoag's object is the galaxy that baffles with beauty, the Black Widow Pulsar is the cosmic predator that chills with its brutality. This isn't just a dead star, it's a killer, spinning at impossible speeds while slowly devouring its companion in one of the most violent relationships in the galaxy. Discovered lurking in the constellation Sagittarius, this pulsar earned its sinister nickname for a reason. Like its arachnid namesake, it consumes its partner, leaving behind only traces of what once was. Pulsars are already among the universe's most extreme objects, collapsed cores of massive stars, crushed into spheres no bigger than a city yet denser than the sun. But the Black Widow takes it further. It spins 742 times per second, a blur so fast its surface moves at nearly a quarter the speed of light. That dizzying rotation whips up a hurricane of radiation and charged particles, a lethal wind that batters the hapless star orbiting just 2 million kilometers away, closer than some planets hug their suns. And here's where it gets gruesome. That stellar wind isn't just pushing the companion star, it's eroding it, stripping away layers of gas atom by atom. Astronomers can actually see the victim's material spiraling into the pulsar, a glowing tail of plasma stretching across space like cosmic breadcrumbs. Over millions of years, this relentless assault will reduce the star to a husk, or worse, vaporize it entirely. It's a slow-motion murder broadcast across the galaxy in X-rays and radio waves. What makes the Black Widow even stranger is how it defies expectations. Most millisecond pulsars, the speed demons of the neutron star world, should spin down over time, their energy fading. But this one, it's a cosmic vampire stealing mass from its companion to fuel its relentless rotation. Some scientists think it might even be accelerating, growing faster as it feeds. And then there's the aftermath. If the companion star vanishes entirely, the Black Widow will float alone, a silent predator with no prey left to hunt. But for now, it offers a front-row seat to one of nature's most ruthless displays. A star eating its neighbor alive, proving once again that the cosmos runs on violence as much as beauty. Even as the cosmos serves up Black Widows and galactic bullseyes, it still has surprises up its sleeve. like the ghostly giants known as odd radio circles or Oort. These enormous rings of radio emission, some wider than entire galaxies, appeared out of nowhere in telescopic surveys just 4 years ago, and they've been confounding astronomers ever since. Picture a cosmic smoke ring, but one so vast it could encase multiple Milky Ways, and unlike anything else in the known universe, these structures emit nothing but radio waves. No visible light, no X-rays, just haunting whispers in the static of space. When researchers first spotted ORCs, they assumed it was an equipment glitch. But as more of them emerged, each one a perfect fading circle suspended in the void, it became clear this wasn't an error, it was a phenomenon. The mystery only deepens when you realize these rings aren't tied to any visible object. No galaxy anchors them, no star cluster pulses at their cores. They simply exist, glowing faintly like afterimages of some colossal, unseen event. So what are they? One leading theory suggests ORCs might be the aftermath of a supermassive black hole's tantrum, an eruption so violent it sent shockwaves rippling through intergalactic gas, leaving behind a bubble of radio emission as it expanded. Imagine throwing a rock into a pond, then watching the ripples freeze mid-spread. But here's the catch: if that's true, why don't we see the black hole that caused it? Where's the wreckage? Another idea points to galactic winds, rivers of charged particles spewed by frenzied star formation, colliding with the thin gas between galaxies, creating a spherical shockwave. Yet even that doesn't quite fit. ORCs are too symmetrical, too isolated, with none of the messy turbulence you'd expect from such chaos. And then there's the wildcard possibility. ORCs could be the scars of a neutron star merger tsunami, the ripples from colliding dead stars so powerful they warp the surrounding gas into a temporary glowing tombstone. But if that's the case, why do these circles linger for millions of years, fading so slowly? What makes ORCs especially tantalizing is their potential to rewrite astrophysics. They might be the fingerprints of an entirely new class of cosmic event, one we've never even named yet. Every time we think we've mapped the universe's playbook, it throws in a new rule. ORCs are that rule, written in radio waves, waiting for us to decode it. Most black holes sit at the heart of galaxies like cosmic anchors, holding entire star systems in their gravitational grip. But not this one. Astronomers recently spotted something no one expected: a supermassive black hole, weighing 20 million times the mass of our Sun, rocketing through intergalactic space at breakneck speed. And it's not traveling alone. Behind it stretches a never-before-seen cosmic contrail, a 200,000 light-year-long river of newborn stars glowing like breadcrumbs left by a celestial fugitive. This isn't just a rogue black hole, it's a runaway. Observations from the Hubble Space Telescope reveal the beast was violently ejected from its home galaxy, likely the result of a gravitational tug-of-war between 3 merging galaxies. When supermassive black holes collide, the resulting kick can send the loser hurtling outward like a cosmic cannonball. But here's what's bizarre: this black hole didn't just leave quietly. As it plows through the thin gas between galaxies, its sheer speed is triggering star formation in its wake. Picture a speedboat's wake, except instead of water, it's churning up baby stars, hot, blue, and impossibly young, in a region of space where stars shouldn't exist at all. The physics behind this stellar trail is even wilder. Normally, black holes devour matter, but this one's motion is so extreme, gas can't fall into it fast enough. Instead, it piles up along the edges of the black hole's path, compressing and heating until new stars ignite like fireflies in the dark. It's the first direct evidence of a black hole acting as a cosmic matchmaker, forcing star birth through pure kinetic chaos. And then there's the trajectory. This black hole isn't just wandering aimlessly, it's on a one-way trip to nowhere, with enough speed to escape its galaxy cluster entirely. Given time, it'll vanish into the void between superclusters, a dark giant adrift in an ocean of emptiness. the implications rattle our understanding of how black holes shape the universe. If these runaways are common, they could seed star formation in the most desolate corners of space, rewriting the rules of where and how galaxies might arise. For now, this celestial outlaw remains a singular spectacle, a monster that fled its throne, painting the cosmos with starlight as it goes. One thing's certain, the universe has a flair for the dramatic, and this black hole is playing the lead. The Milky Way holds secrets on scales so vast they dwarf our entire solar system, none more striking than the Fermi Bubbles, twin behemoths of gamma-ray energy stretching 25,000 light-years above and below the galactic center. Picture two colossal hourglasses of raw radiation, glowing like ghostly lungs breathing out into the void. Discovered just over a decade ago by NASA's Fermi Gamma-Ray Space Telescope, these structures aren't just big, they're alive with motion, their edges crackling with particles moving at near light speed. And the most unsettling part, something or someone forgot to tell us how they got there. One theory points to the supermassive black hole at our galaxy's heart, Sagittarius, a star, as the culprit. Imagine it gorging on a gargantuan meal of gas and stars millions of years ago, then belching out twin jets of energy so powerful they punch through the Milky Way's disk, inflating these bubbles like cosmic balloons. The math almost fits. The energy required matches what a ravenous black hole might produce during a feeding frenzy. But here's the hitch: we've never caught Sagittarius, a star, acting violently enough to explain it. Where's the evidence of this ancient cataclysm? Then there's the star party hypothesis. The galactic center is a factory for massive stars, and their explosive deaths could have collectively pumped enough energy into space to sculpt the bubbles. Think of it as a million supernovae shouting in unison, their shockwaves merging into a single, deafening echo. Yet even that doesn't fully account for the bubbles' razor-sharp edges or their bizarre symmetry. Nature rarely builds with such precision unless something's directing the show, and the plot thickens when you study the bubbles' composition. They're not just hot gas, they're threaded with magnetic fields stronger than expected, wrangling particles into high-energy dances. Some researchers suggest dark matter might be pulling strings behind the scenes, its annihilation fueling the glow. Others wonder if the bubbles are fossils from a time when the Milky Way collided with another galaxy, a trauma written in gamma rays. What's clear is that the Fermi Bubbles are a snapshot of violence frozen in time, a relic of forces we're only beginning to grasp. They remind us that even our home galaxy has a temper, capable of eruptions that reshape space itself. Until we peer deeper into their origins, they'll loom over us, a silent warning that the cosmos never runs out of surprises. While most dead stars fade quietly into the cosmic backdrop, the Cannonball Pulsar is anything but subtle. This neutron star is hurtling through the galaxy at a staggering 2.5 million miles per hour, so fast it could cross the distance from Earth to the Moon in just 6 minutes. Imagine a city-sized object heavier than the Sun, moving with enough force to leave a visible scar in the fabric of space itself. That's exactly what this cosmic bullet is doing, carving a bow shockwave through interstellar gas like a speedboat plowing through water. What makes the Cannonball Pulsar so mesmerizing isn't just its speed, it's the violence of its birth. Most neutron stars form when massive stars collapse in supernova explosions, but few get kicked into motion with this much ferocity. Scientists believe this particular pulsar was launched by an asymmetrical explosion, where one side of the dying star detonated more powerfully than the other. The imbalance acted like a natural rocket engine, flinging the newborn neutron star across the galaxy with enough force to escape its home star cluster entirely. The aftermath is written in light. As the pulsar barrels through space, its magnetic field rams into surrounding gas, compressing and heating it until it glows. The result, a colossal, crescent-shaped shockwave visible in X-rays, a cosmic wake marking the path of this runaway star. The sheer force of its motion even deflects the galaxy's magnetic fields, bending them around its trajectory like invisible rails. But here's the real mystery. Where is it headed? Tracing its path backward suggests the cannonball pulsar likely originated near the heart of the Milky Way, possibly ejected by the supermassive black hole lurking there. If that's true, it's a rare glimpse into the chaotic mechanics of our galaxy's core, where gravitational forces can Hulk smash objects into hyperdrive. And yet, for all its fury, the cannonball pulsar is doomed to fade. Over millions of years, its speed will bleed away as it interacts with interstellar gas, and its shockwave will dissipate like a fading echo. But for now, it serves as a blazing reminder. The universe doesn't just create, it launches with forces beyond comprehension. Buried deep in the Milky Way's halo, hidden in plain sight among billions of stars, lies a celestial relic so massive it reshaped our galaxy forever, the Gaia sausage. Don't let the playful name fool you. This isn't some cosmic snack. It's the mangled corpse of an ancient dwarf galaxy, a victim of the Milky Way's gravitational appetite. 8 to 10 billion years ago, this ill-fated neighbor, roughly 1/10 our galaxy's size, plunged headfirst into the young Milky Way in a collision so violent, it left scars we're only now deciphering. The key to uncovering this galactic crime scene wasn't brightness or color, but motion. Thanks to the European Space Agency's Gaia mission, which maps the positions and velocities of over 1 billion stars, astronomers noticed something bizarre. Thousands of stars moving like a school of fish against the Milky Way's current. Instead of orbiting the galactic center in orderly loops, these stars dart radially, shooting toward and away from the core like bullets frozen mid-trajectory. Plot their paths and they form a peculiar, sausage-shaped distribution in space, a smoking gun of an ancient impact, but the real revelation lies in the chemistry. These stellar interlopers carry a distinct signature. Heavier elements like iron are scarce compared to Milky Way natives, betraying their origin in a smaller, poorer galaxy. Their orbits are chaotic, too tilted at sharp angles, as if the gravitational shockwave of the collision sent them careening like pins after a strike. Some even loop backward, defying our galaxy's rotation. It's as if we're staring at the scattered debris of a cosmic car crash, frozen in time. This wasn't just a glancing blow. Simulations suggest the Gaia sausage galaxy was torn apart so thoroughly. Its stars were smeared across tens of thousands of light years, seeding the Milky Way's halo with their remnants. The impact might have even triggered furious bursts of star formation, puffing up our galaxy's disk into the spiral we recognize today. Here's the twist: the Gaia sausage core may still be with us. Some scientists suspect its heart survived as the galaxy's dark matter skeleton, anchoring its orphaned stars in an invisible gravitational embrace. Now, every time we gaze at the night sky, we're looking at a galactic hybrid, part Milky Way, part cannibalized stranger. The Gaia sausage isn't just a fossil. It's a reminder that galaxies grow by devouring their neighbors, and our cosmic home is no exception. The universe writes its history in collisions, and this one's signature is written in the trajectories of 1 billion fleeing stars. Among the chaotic beauty of cosmic nebulae, where swirling clouds of gas paint the universe in abstract splendor, one structure stands out with almost unsettling precision: the Red Rectangle Nebula. This cosmic jewel, nestled 2,300 light-years away in the constellation Monoceros, isn't just another dying star's farewell. It's a geometric masterpiece, a near-perfect X-shape glowing with an eerie crimson hue, as if the universe itself drafted it with a ruler and compass. At its heart lies a binary star system, HD 44179, where an aging sun-like star pumps out jets of gas and dust in its death throes. But unlike the usual chaotic ejections of planetary nebulae, this star's outbursts have sculpted something extraordinary. concentric rings of red glowing material stacked like cosmic tree rings, all funneled into that striking X-shaped lattice. The vibrant red comes from a rare form of carbon-rich molecules called polycyclic aromatic hydrocarbons, essentially soot lit up by the dying star's ultraviolet fury. It's as if the cosmos decided to paint with a palette of embers and geometry. What truly baffles scientists isn't just the nebula's shape, but how it stays so precise. Most dying stars spew their material in all directions, creating billowing, asymmetrical clouds. The red rectangle's razor-sharp edges suggest something is corralling the chaos, likely a dense disk of dust around the central star, acting like a stencil for the escaping gas. As the star's winds slam into this disk, they're forced outward along its poles, carving those iconic X-shaped jets. Meanwhile, the disk itself casts shadows, creating the illusion of stepped rungs in the nebula's structure, a staircase to nowhere. But even that explanation leaves gaps. Why do the X's arms glow brighter at their tips like celestial sparklers? Why does the red deepen toward the edges as if the nebula is blushing? Some theorists propose magnetic fields are at play, twisting the outflow into its orderly form. Others wonder if the companion star in the binary system is stirring the pot, its gravity sculpting the ejector like an invisible hand. Then there's the nebula's fate. In a few thousand years, the central star will heat up, ionizing the surrounding gas and transforming the red rectangle into a classic planetary nebula, erasing its geometric perfection forever. For now, though, it remains a fleeting cosmic artwork, a reminder that even in death, stars can create symmetry so exact it feels almost designed. One glance at its crimson lattice and you're left wondering, is this nature's randomness or a hint of hidden order we've yet to understand? If we could strip away the Milky Way's glittering stars and glowing gas, we'd be left with something far stranger, an invisible giant, a shadowy colossus holding our entire galaxy together. This is the dark matter halo, a vast sphere of something enveloping the Milky Way like an unseen hand gripping a spinning coin. It's 5 times more massive than all the visible matter in our galaxy combined, yet we've never directly detected it. How do we know it's there? Because without its gravitational glue, the Milky Way would fly apart, its stars scattering into the void like beads from a snapped necklace. Take our galaxy's rotation curve, the speed at which stars orbit the center. By all rights, stars farther out should move slower, just as Pluto crawls compared to Mercury. But they don't. Instead, stars at the Milky Way's fringe whip around just as fast as those near the core. The only explanation, an enormous, invisible mass must be tugging on them, its gravity sculpting the galaxy's motion from the shadows. Simulations show this dark matter isn't just sprinkled between stars, it forms a colossal, diffuse sphere stretching hundreds of thousands of light years beyond the visible galactic disk. Picture a lighthouse engulfed in fog, where the light is the Milky Way and the fog is the halo 10 times wider. But what is this stuff? The leading suspects sound like sci-fi, WIMP, or weakly interacting massive particles, hypothetical subatomic entities that barely touch normal matter, passing through planets and us like ghosts. Then there are actions, ultra-lightweight particles that might behave more like waves than particles, sloshing through the cosmos. Some theories even suggest primordial black holes, forged in the Big Bang's first seconds, could lurk in the halo. But whatever dark matter is, it refuses to play nice. Countless experiments have tried to catch it, from underground labs shielded from cosmic noise to detectors bolted to the International Space Station. So far, silence. The dark matter halo isn't just a passive scaffold. It actively shapes galactic evolution. Simulations reveal how its gravitational tendrils guided the Milky Way's growth, funneling gas into star-forming regions and dictating where satellite galaxies like the Large Magellanic Cloud could orbit. Some researchers believe the halo's uneven lumpiness might explain why our galaxy's outskirts are littered with strange stellar streams, the shredded remains of smaller galaxies consumed long ago. Here's the twist: dark matter might not be one thing, but many. Could it be a mix of WIMP actions and something else entirely? Future telescopes like NAS and Nancy Grace Roman Space Telescope aim to map the halo's structure by watching how its gravity bends light from distant galaxies, revealing its hidden topography. Until then, the dark matter halo remains the ultimate cosmic puppet master, unseen, undeniable, and utterly mysterious. The Milky Way doesn't just have a halo, it's held together by one, a reminder that most of the universe isn't just unknown, it's invisible. The Milky Way brims with bustling star cities and glowing nebulae until you stumble upon a silent abyss so vast it defies comprehension. The Boötes Void isn't just an empty patch of sky, it's a gaping hole in the cosmic web, a spherical desert spanning 330 million light-years where galaxies should thrive but don't. If you placed the Milky Way at its center, you'd need to travel a quarter of the way across the observable universe just to reach the other side, and in all that unimaginable space. Only 60 galaxies cling to existence, lonely specks adrift in a sea of nothingness. This void challenges everything we know about how the universe structures itself. Normally, galaxies cluster like fireflies in a summer field, drawn together by gravity's invisible strings. The nearby Sloan Great Wall, for instance, is one of the largest known superclusters, a filament of galaxies stretching over 1.4 billion light-years, so dense it resembles a continent in the sky. But the Boötes Void, it's the antithesis, a cosmic ghost town where matter seems to have vanished without a trace. So how does a void this colossal even form? One theory suggests it's a fossil from the universe's infancy, where quantum fluctuations left some regions unnaturally sparse. As space expanded, these underdense patches ballooned into today's voids. Another idea proposes that smaller voids merged over billions of years, their emptiness stacking like soap bubbles until they formed this incomprehensible nothing. Yet neither explanation fully accounts for the Boötes Void's staggering scale or its eerie symmetry. Then there's the wild-card hypothesis: what if it's not natural at all? Some theorists half-jokingly suggest an advanced Type 3 civilization could have harnessed the energy of entire galaxies, leaving behind an engineered wasteland. While there's zero evidence for this, the sheer scale of the void forces us to confront how little we understand about the universe's true structure. Even more unsettling, the Boötes Void might not be alone. Recent sky surveys hint at even larger voids lurking in the cosmic shadows, regions where the fabric of reality stretches thin and dark. They remind us that the universe isn't just a tapestry of light. It's also a labyrinth of absence where emptiness itself holds secrets we're only beginning to fathom. Most planets are made of rock, gas, or ice, but Pulsar J1719-1438b is something else entirely. Imagine a world where the very ground beneath your feet isn't just rich in carbon, it's a single planet-sized diamond. Orbiting a pulsar 4,000 light-years away in the constellation Serpens, this exotic gem of a planet defies every expectation of what a world can be. The story starts with its parent star, a millisecond pulsar spinning so fast it completes over 10,000 rotations every minute. That dizzying speed tells astronomers something crucial: this dead star wasn't always alone. It gorged on a companion, siphoning off material until only the densest core remained. But here's the twist: that companion might not have vanished completely. Scientists believe the diamond planet is all that's left, the skeletal heart of a white dwarf star stripped down to its most indestructible elements. Here's how the cosmic alchemy works. White dwarfs are the smoldering cores of dead stars packed with carbon and oxygen. Under normal circumstances, they cool slowly over billions of years. But when a pulsar's gravity begins cannibalizing one, the intense pressure can crush the carbon into crystalline perfection, a diamond the size of a planet. Pulsar J1719-1438b fits this gruesome origin story perfectly. roughly 5 times Earth's mass yet just half its width. Its density suggests a composition so compressed, it's likely crystallized carbon all the way through. But the real marvel is what happens on the surface. Picture a landscape where mountains aren't stone but faceted diamond, reflecting the pulsar's strobe like beams in blinding flashes. The planet's tight orbit, just 600,000 kilometers closer than Mercury hugs the Sun, means its day side roasts in relentless radiation, while the night side plunges into eternal cold. If there were any atmosphere, the pulsar's fury would have vaporized it long ago, leaving behind nothing but a glittering, airless jewel adrift in the dark. And then there's the sound. Pulsar planets don't experience wind or weather, just the rhythmic ticking of their dead stars' radio pulses, sweeping across the diamond plains like a cosmic lighthouse. Every few hours, the entire planet is bathed in bursts of radiation intense enough to vaporize steel, its surface sparkling not with reflected sunlight, but with the eerie glow of atomic interactions. Could we ever mine such a world? In theory, yes, but the logistics are laughable. Even if we could reach it, the diamond planet's gravity would crush any probe, and its proximity to the pulsar would fry electronics instantly. Besides, flooding Earth's markets with a planet's worth of diamonds would make them as worthless as gravel. What makes Pulsar J1719-1438b truly special isn't just its composition, it's the violence of its creation. This isn't just a dead star's remnant, it's a celestial phoenix forged from annihilation. A diamond, after all, is just coal that survived pressure. And this planet, it's proof that even in the darkest corners of space, destruction can create something breathtaking. Rising from the chaos of the Carina Nebula like a cosmic cathedral, the mystic mountain towers stand as one of the most breathtaking structures ever photographed in our galaxy. These 3 light-year-tall pillars of dust and gas aren't just beautiful, they're violent stellar nurseries, where newborn stars literally blast their way into existence, sculpting the surrounding chaos with shockwaves of radiation. When Hubble captured this region in 2010, it revealed a landscape so surreal, astronomers initially struggled to find earthly comparisons. The tallest peak stretches 7 trillion kilometers from base to summit, enough to swallow our solar system 50,000 times over. What makes these formations so extraordinary isn't just their scale, but the celestial drama unfolding within them. Unlike the static mountain ranges of Earth, the mystic mountain is a battlefield between creation and destruction. Each dusty spire is riddled with protostars' infant suns still wrapped in their gaseous cocoons. As these stellar embryos awaken, their fierce ultraviolet radiation carves away the surrounding material, creating shimmering ridges and caverns that glow with ethereal blues and reds. Some regions blaze with the intensity of newborn stars, while others remain eerily dark, their interiors still collapsing under gravity's relentless pull. Zoom in closer, and you'll spot jets of superheated gas shooting from the pillars' sides at nearly 1,000,000 miles per hour, cosmic fire hoses blasted by stars still in their infancy. These Herbig-Haro objects, as astronomers call them, mark where material spiraling onto young stars gets channeled into narrow beams by powerful magnetic fields. It's a stellar tantrum of unimaginable force, yet on the cosmic scale, it merely wrinkles the surface of these gargantuan structures, but the mystic mountain won't last. The very stars it's birthing will be its undoing. Radiation from massive nearby stars, especially the monster Eta Carinii, 70 times heavier than our Sun, is evaporating the pillars at a staggering rate. Computer simulations suggest they'll be completely obliterated within the next 100,000 years, their dust and gas scattered back into the nebula to form new generations of stars. That fleeting nature makes Hubble's portrait all the more precious, a snapshot of a celestial artwork destined to vanish. Perhaps the most humbling realization is that our own Sun likely formed in a similar stellar nursery billions of years ago. The same forces carving the mystic mountain gravity's collapse, radiation's push once sculpted the cloud that became our solar system. These pillars aren't just alien landscapes, they're echoes of our cosmic origins, written in swirling dust and newborn starlight. When you gaze at their intricate folds and glowing tendrils, you're seeing the universe's creative process laid bare, beauty born from chaos, destruction giving way to rebirth. In the depths of the constellation Virgo, a cosmic corpse spins relentlessly, its dead heart still dictating the fates of worlds that shouldn't exist. This is PSRB 1257+12, better known as the Lick Pulsar, a neutron star that died in a cataclysmic supernova explosion yet somehow kept its planets. Not just any planets either. These are the ultimate survivors, worlds that clung to existence even as their star tore itself apart in one of the universe's most violent events. Astronomers call them zombie planets, and their mere existence rewrites the rules of how planetary systems form and how they die. When the Lick Pulsar was first discovered in the 1990s, it shattered expectations. Pulsars are the crushed cores of massive stars, so dense a teaspoon of their material weighs as much as a mountain. They form when a star implodes, its outer layers blasted into space in a supernova so powerful it can outshine entire galaxies. Conventional wisdom said any planets orbiting such a star would be vaporized, or at least flung into the void by the explosion's shockwave. Yet here, circling this stellar gravestone, were three rocky worlds, stubbornly holding on like passengers clinging to a sinking ship. The most baffling part, these aren't just scorched remnants. One of them, dubbed Draugr, is barely twice Earth's mass, a lightweight by cosmic standards, while its siblings, Poltergeist and Phobter, are roughly 4 times as massive. All three orbit breathtakingly close to their undead star, completing full revolutions in mere days. Their surfaces, if they even have solid ones, would be bathed in relentless radiation, their skies lit by the pulsar's eerie, rhythmic strobe of gamma rays and radio waves. But how did they get here? One theory suggests these worlds were born after the supernova, forming from the ashes of the destroyed star. As the ejected material cooled, it might have collapsed into a disk around the pulsar, much like the protoplanetary disks where normal planets form. The problem, the sheer intensity of a pulsar's radiation should prevent dust grains from sticking together long enough to build planets, yet somehow, against all odds, they did. Then there's the darker possibility. These planets were there before the star exploded, gas giants or rocky super-Earths that somehow weathered the apocalypse. If true, their cores might be the only surviving fragments of a once thriving system, their outer layers stripped away by the blast, leaving behind skeletal husks. Imagine a skyscraper surviving a nuclear detonation, its steel frame twisted but still standing. That's the level of resilience we're talking about. What makes the Lick system even stranger is its resemblance to parts of our own solar system. The orbits of Draugr, Poltergeist, and Phobter mirror a scaled-down version of Mercury, Venus, and Earth, a ghostly echo of familiar patterns in the most hostile environment imaginable. Could this mean planet formation is more universal than we thought, able to occur even in the wreckage of stellar death? Whatever their origin, the zombie planets of the Lick Pulsar force us to rethink the boundaries of survival. If worlds can endure the unimaginable violence of a supernova, what else might be lurking in the graveyards of dead stars? The universe, it seems, has a habit of nurturing life, or at least its potential in the unlikeliest of places. And these undead worlds, spinning silently around their long-dead star, are proof that even in the ashes of destruction, new mysteries take root. Rising from the galactic core like twin tsunamis of pure energy, the Milky Way's colossal geysers blast outward for 50,000 light-years, 25,000 above and below the disk, spewing enough high-energy particles to power 1 trillion suns. These aren't gentle fountains, they're titanic outflows, a tempest of cosmic proportions erupting from the heart of our galaxy, and at the center of this maelstrom. The prime suspect, Sagittarius, a star, the supermassive black hole lurking in the Milky Way's dark heart. What makes these geysers so extraordinary is their sheer violence. Imagine a volcanic eruption, but instead of molten rock, it's a storm of protons and electrons accelerated to near light speed, glowing in gamma rays as they collide with interstellar gas. The energy here is unimaginable. Each particle carries millions of times more punch than anything produced in Earth's most powerful particle accelerators. Yet despite their fury, these geysers remained hidden until 2010, when NASA's Fermi Gamma Ray Space Telescope peeled back the veil, revealing two vast lobes of energy bracketing the galaxy like wings of fire. The question is, what unleashed them? One leading theory points to Sagittarius, a star's tumultuous past. Supermassive black holes aren't always quiet neighbors. When they feed, they erupt. Astronomers speculate that millions of years ago, our black hole may have gorged on a massive gas cloud or even a wayward star, its gravity shredding the victim apart. As the debris spiraled inward, some of it could have been funneled into jets, channeled by the black hole's intense magnetic fields and blasted into intergalactic space. The result, a pressure wave so powerful it punched through the Milky Way's dense central region, inflating these colossal particle bubbles. But there's a twist. The geyser's energy signature doesn't perfectly match what we'd expect from a black hole's jets. That's led some scientists to propose an even wilder origin: dark matter annihilation. If hypothetical dark matter particles like WIMP collide and destroy each other near the galactic center, they'd release bursts of gamma rays. Over time, these collisions could build up enough energy to launch the geysers, turning the Milky Way's core into a particle accelerator of cosmic proportions. It's a tantalizing idea because, if true, these outflows could be our first indirect glimpse of dark matter's hidden physics. Then there's the structure itself. Unlike the Fermi bubbles, another set of mysterious structures surrounding the galactic center, the geysers are more structured, their edges crisper. Some researchers think they might be the remnants of multiple eruptions, layered like tree rings, each outburst adding to the geyser's height. Others suggest magnetic fields are sculpting the particles into these vast, coherent shapes, acting like invisible rails guiding the chaos. One thing's certain: the geysers aren't static. They're still active, still expanding, though at human timescales they appear frozen. Every second, more particles join the outflow, riding the galactic winds into the halo. Over millions of years, they'll eventually dissipate, their energy bleeding into the void. But for now, they stand as a monument to the Milky Way's hidden fury, a reminder that even our home galaxy has a temper. And when it erupts, the universe feels it. Out in the depths of the Milky Way floats a celestial mystery wrapped in ultraviolet light, the Blue Ring Nebula. At first glance, it looks like a pale blue smudge, an unremarkable halo around a dim star. But this isn't just another stellar corpse. It's the only known example of a star caught in the act of transforming from two into one. A fleeting cosmic metamorphosis that astronomers have been chasing for 16 years without fully understanding. What makes this nebula so extraordinary isn't just its color. It's the fact that we're witnessing a phase of stellar evolution so brief, it should have vanished long before we ever pointed our telescopes in its direction. The story begins in 2005 when astronomers spotted an unusual star surrounded by a faint, ring-shaped glow in ultraviolet light. Unlike planetary nebulae, the glowing shrouds of dying stars, this ring showed no signs of heavy elements or complex structures. Instead, it was a near-perfect sphere of ionized hydrogen, rippling outward like a shockwave frozen in time. Even stranger, the star at its center wasn't the expected red giant or white dwarf. It was a seemingly ordinary star with one quirk: its outer layers were spinning far too fast, as if it had been violently spun up by some unseen force. Then came the breakthrough: this star wasn't always alone. The Blue Ring Nebula is what happens when two stars in a tight binary system finally merge, their dance of death triggering a catastrophic explosion that flings debris into space. The ultraviolet ring, that's the aftermath, the cooling remnants of the smaller star's outer layers, lit up by the intense radiation from the newly merged core. Most mergers fade within centuries, but this one, by sheer cosmic luck, has lingered just long enough for us to catch it, but the real treasure lies in the details. The nebula's structure reveals a hidden cone of material shooting out above and below the ring, invisible in optical light but blazing in infrared. These cones are the fingerprints of the merger's violence, jets of gas ejected at the moment the stars collided. Meanwhile, the central star's bizarre chemical composition, lacking certain elements, enriched with others, hints at the smaller star's final moments, its material churned and diluted in the cosmic blender of the merger. What makes the Blue Ring Nebula truly priceless is its rarity. Stellar mergers are common statistically, they should happen all across our galaxy. Yet we've never seen one in this exact phase, a snapshot of the chaos between the merger's fireball and its fading embers. It's like stumbling upon a photograph of a butterfly mid-metamorphosis, wings still damp and crumpled, caught between caterpillar and flight. Now, after 16 years of observation, astronomers are racing to decode its secrets before the light fades. Every new spectrum, every flicker of its ultraviolet glow brings us closer to understanding how binary stars die, and how their deaths seed the galaxy with the elements needed for new worlds. The Blue Ring Nebula won't last forever, but for now, it's a luminous clue to one of the universe's most chaotic yet creative acts. Deep in the heart of the Milky Way, hidden among the swirling arms of our galaxy, lurk some of the universe's most unpredictable senior citizens, the old smoker stars. These aren't your typical red giants quietly burning through their final fuel. These volatile elders have a habit of coughing up colossal clouds of dust and gas without warning, shrouding themselves in cosmic smog for years, even decades before clearing up as if nothing happened. Imagine a star that spends most of its life as a faint ember, only to suddenly exhale a smoke screen so thick it dims its own light by up to 90%. That's the baffling spectacle astronomers have only recently begun to unravel. What makes these stars so strange isn't just their erratic behavior, it's what they're spewing into space. Unlike the violent eruptions of supernova or the steady winds of younger stars, old smokers produce dense, carbon-rich clouds packed with organic molecules. We're talking complex compounds like polycyclic aromatic hydrocarbons, the same building blocks found in soot, coal, and even some of the precursor materials for life. When one of these stars has a smoking fit, it isn't just hiding itself from view, it's effectively seeding the surrounding cosmos with the raw ingredients for future planets and possibly even biology. The mechanics behind these dust burps are still a mystery. One theory suggests that as these aging stars expand, their outer layers cool just enough for carbon atoms to clump together into solid particles like flakes of cosmic ash. Normally, stellar winds would blow this dust away, but in old smokers, something, perhaps magnetic fields or shockwaves, traps the material close to the star until it reaches a tipping point. Then, like a pressure cooker venting steam, the star unleashes a cloud massive enough to blanket entire solar systems. Even more intriguing, these events might be far more common than we ever suspected. Recent infrared surveys have spotted dozens of candidates lurking in the Milky Way's bulge, many of them previously overlooked because their dimming events unfold over such long timescales. Unlike the dramatic flares of nova which grab headlines, old smokers operate on a slow burn. Their change is subtle enough to evade detection unless you're watching patiently for years. But the real game changer is their potential role in galactic chemistry. If these stars are indeed pumping out organic, rich dust, they could be unsung architects of the universe's molecular diversity, spreading life's potential ingredients far and wide. Every time an old smoker clears its throat, it might be fertilizing the cosmos with the very stuff that could one day form planets or even life. For now, these celestial enigmas keep astronomers on their toes, a reminder that even the oldest stars still have surprises up their sleeves. In a universe often defined by cataclysmic violence, there's something poetic about the idea that one of its quietest acts, a senior star taking a cosmic breath, could hold the key to seeding the galaxy with the building blocks of existence. While most stars move in predictable orbits around the galactic center, a handful of celestial rebels break all the rules. The hypervelocity stars, these cosmic outlaws, rocket through the Milky Way at speeds exceeding 1.5 million miles per hour. So fast they're not just leaving their neighborhoods, they're escaping the galaxy entirely. And the force behind their exile, none other than the supermassive black hole lurking at the heart of the Milky Way, acting like a monstrous gravitational slingshot. The story begins with binary star systems, pairs of stars locked in a mutual dance. If one strays too close to Sagittarius, a star, our galaxy's central black hole, the immense tidal forces can rip the duo apart. One star gets captured in a tight orbit, while the other is violently ejected in the opposite direction, flung outward at velocities that defy comprehension. The math is terrifyingly elegant. The energy stolen from the black hole's rotation gets dumped into the fleeing star, accelerating it to speeds that make even the cannonball pulsar look sluggish. But here's the twist: not all hypervelocity stars come from the galactic center. Some might be survivors of dwarf galaxies torn apart by the Milky Way's gravity, their stars sent careening like shrapnel from a cosmic collision. Others could be the remnants of supernova explosions, where the asymmetrical detonation literally kicks the surviving companion star into the void. The trajectories of these rogue stars trace back to violence, whether from black holes, galactic cannibalism, or stellar explosions. Now picture one of these stars, say S5 HVS1, currently screaming through the constellation Grus at a blistering 3.7 million miles per hour. It's already crossed 60,000 light-years from its likely birthplace near Sagittarius, a star, and in another 100 million years it'll breach the Milky Way's outer halo. After that, intergalactic space, no more star clusters, no nebulae, just an endless ocean of darkness where the nearest galaxy might be millions of light-years away. Yet for all their speed, hypervelocity stars aren't just aimless drifters. Their paths are cosmic breadcrumbs, helping astronomers map the Milky Way's gravitational field. By studying their trajectories, we can infer the distribution of dark matter, the invisible scaffold shaping our galaxy's structure. Even their compositions tell stories. Some are bizarrely metal-rich, suggesting they originated in the crowded, chemically complex environment of the galactic center. What's truly humbling is the loneliness awaiting them. While most stars live and die in the company of others, these exiled suns are destined to burn out in the void, their light fading into the unimaginable vastness between galaxies. Yet in their solitude, they carry secrets of black holes, of galactic collisions, of the volatile forces that sculpt the universe. They remind us that even in the ordered spiral of the Milky Way, chaos always has the final word. Gamma-ray bursts are supposed to be the universe's flashbangs, brief, blinding eruptions of energy so intense they outshine entire galaxies. But in 2008, astronomers caught something that broke all the rules: GRB 080517, a gamma-ray burst that screamed into existence and then vanished without a trace. No afterglow, no fading light show, just a burst of high-energy radiation followed by radio silence, dubbed the Dark GRB. This cosmic oddity wasn't just mysterious, it was a direct challenge to everything we thought we knew about these catastrophic events. Normally, when a massive star collapses into a black hole or neutron stars collide, the resulting gamma-ray blast is just the opening act. What follows is an afterglow, a cascading firework of X-rays, visible light, and radio waves as the explosion's shockwaves plow through surrounding gas. It's this afterglow that lets astronomers pinpoint the burst's origin and study its aftermath. GRB 080517 defied that script. Despite being relatively close, just 6.5 billion light-years away, practically next door in cosmic terms, its afterglow was missing, as if something had swallowed the light whole. The leading suspect, cosmic dust, and not just a few stray particles. We're talking thick, murky clouds so dense they could cloak an entire stellar catastrophe. Picture a flashlight beam hitting a wall of smoke the light scatters, absorbed before it can reach your eyes. That's what might have happened here. If the dying star was buried in a dusty stellar nursery, those same dust grains that help form new planets could have acted like a cosmic smokescreen, muffling the afterglow before it ever reached us. But there's a twist. Some theorists argue this burst might represent something far stranger, a new class of gamma-ray events entirely. What if, instead of dust obscuring our view, GRB 080517 was intrinsically dark, an explosion that simply didn't produce the usual afterglow? The physics behind gamma-ray bursts is already extreme, involving relativistic jets and magnetic fields twisted to breaking point. Could there be a variation where those jets carry less fuel for an afterglow, or where the energy gets channeled in ways we don't yet understand? The implications are staggering. If dark GRBs are real, how many have we missed? Current telescopes are tuned to catch the bright, showy bursts, the ones that announce themselves with fireworks. But if a significant fraction of these events are hidden, cloaked either by dust or their own unusual mechanics, we might be underestimating how often stars die in these apocalyptic explosions. It's like realizing every volcanic eruption you've ever studied was just the loud, explosive kind, while silent, equally powerful ones were slipping by unnoticed. Then there's the elephant in the room. What else might be hiding in those dusty corners of the universe? GRB 080517 could be the tip of the iceberg, a hint that our observational toolkit has blind spots we're only beginning to uncover. When even the universe's most violent events can vanish without a trace, it forces us to ask, what other cosmic spectacles are playing out just beyond the limits of our sight? For now, the dark GRB remains an enigma, a burst that defies categorization, and in doing so, reminds us that the universe always keeps a few secrets in reserve. Whether it's dust or something more exotic cloaking these events, one thing's certain: the cosmos still has surprises up its sleeve, and some of them don't play by the rules. Most galaxy clusters are cosmic graveyards for star formation, vast expanses of superheated gas where temperatures soar to millions of degrees, far too hostile for delicate stellar nurseries to take root. But the Phoenix cluster laughs in the face of expectations. Located 5.7 billion light-years away in the constellation Phoenix, this gargantuan structure isn't just defying the rules, it's rewriting them. At its heart lies a storm of creation, where stars are being born at a rate roughly 20 times faster than in our entire Milky Way, all while swimming in an ocean of plasma hot enough to vaporize planets. What makes the Phoenix cluster so revolutionary is its ability to sustain what astronomers call a cooling flow, a phenomenon long theorized but rarely observed in such spectacular fashion. Normally, the superheated gas at the center of galaxy clusters should remain scorching, kept at bay by the energy blasts from supermassive black holes. These black holes act like cosmic pressure valves, erupting with jets of radiation that prevent the gas from cooling enough to collapse into stars. But the Phoenix cluster isn't playing by those rules. Despite its own central black hole, a behemoth with the mass of 20 billion suns, the gas here is cooling faster than the black hole can reheat it. The result: a downpour of star formation so intense, it's birthing roughly 740 new stars per year, transforming the cluster's core into a stellar factory of unparalleled scale. The mechanics behind this cosmic defiance are as mesmerizing as they are counterintuitive. X-ray observations reveal rivers of gas, some as massive as 1 trillion suns, slowly trickling toward the cluster's center, cooling as they go. This gas should be boiling away under the black hole's fury, yet instead, it condenses into dense, star-forming clouds. Think of it like a pot of water left to simmer on a stove, except the burner is on full blast and the water keeps freezing. The Phoenix cluster shouldn't be possible, and yet here it is. Some scientists suspect the cluster's black hole might be in a rare, quiet phase, its jets misaligned or too weak to disrupt the cooling gas effectively. Others propose that the sheer density of the inflowing gas is overwhelming the black hole's feedback mechanisms, like a fire hose blasting through a candle flame. Then there's the wildcard idea. What if dark matter's gravitational pull is subtly altering the gas dynamics, funneling material into regions where the black hole's influence can't reach? Whatever the cause, the Phoenix cluster is forcing astronomers to rethink how galaxies evolve. If cooling flows can persist even in the presence of monstrous black holes, entire models of galactic growth might need revision. This isn't just a cluster, it's a cosmic laboratory, revealing the delicate balance between creation and destruction in the universe's most extreme environments. And for star formation, it proves one thing: even in the furnace of space, life finds a way. In the constellation Norma, tucked within a glowing nest of gas and dust, lies a celestial oddity so perfectly unbalanced it seems almost intentional: the Dragon's Egg Nebula. At its heart, two stars orbit in an uneasy embrace, locked in a cosmic tug-of-war where one star's magnetic might has tamed the fury of its sibling. The larger of the pair, a blue giant known as HD 148937, is no ordinary star. It's a magnetic colossus, its field strength 20,000 times stronger than Earth's, so powerful it acts like an invisible cage, corralling the stellar winds of its smaller, volatile companion. Picture this: the smaller star, a scorching, restless orb, flings charged particles into space at speeds topping 8 million miles per hour. Under normal circumstances, these winds would spiral outward in chaotic plumes, shaping the surrounding nebula into asymmetrical swirls. But the Dragon's Egg defies expectations. As the winds rush toward the blue giant, they slam into its magnetic prison, bending and twisting into a sculpted arc that glows like a dragon's coiled tail in ultraviolet light. The result, a nebula of eerie symmetry, its delicate loops and cavities etched by an invisible hand. This isn't just a pretty cosmic snapshot, it's a rare laboratory for extreme astrophysics. Magnetic fields this strong are almost unheard of in stars of this size, and their presence here raises tantalizing questions. Did the star steal this field from a past companion? Was it born with this freakish magnetism? What's clear is that the field isn't just redirecting winds, it's stifling them, forcing the smaller star's outbursts into a tightly controlled dance. The energy doesn't vanish, it funnels into the nebula, lighting up filaments of gas like neon signs in a celestial alleyway. But the real marvel lies in the equilibrium. Despite their lopsided power dynamic, these stars aren't tearing each other apart. Instead, they've settled into a fragile truce, a feedback loop where the magnetic star's dominance shapes the nebula, which in turn shields both stars from the full brunt of interstellar radiation. It's a self-regulating system, a cosmic yin and yang where chaos and order find temporary balance. And then there's the nebula's namesake glow, a golden-orange haze reminiscent of an eggshell, lit from within by the trapped energy of those stifled winds. Within it, pockets of gas collapse under gravity's pull, hinting at new stars forming in the shadow of this strange partnership. The Dragon's Egg isn't just a celestial curio, it's proof that even in the vast, uncaring cosmos, relationships, however unequal, can carve beauty from chaos. Far beyond Neptune's icy realm, where sunlight fades to a dim memory, a tiny world traces an orbit so stretched it defies belief. Meet the Goblin, officially known as TG387, a dwarf planet candidate whose 40,000-year journey around the Sun reads like a cosmic mystery novel. Discovered in 2018, this frozen relic doesn't just drift lazily through the solar system's outskirts. It slingshots from the inner edge of the Oort cloud to a mind-bending 2,300 astronomical units at its farthest, so distant, the sun appears as just another twinkle in the sky. But what makes the Goblin truly remarkable isn't just its extreme path, it's the way its dance seems choreographed by an unseen hand, a gravitational puppeteer lurking in the dark. The Goblin's orbit is no random fluke. Like a handful of other extreme trans-Neptunian objects, its trajectory clusters in a way that suggests something massive. Perhaps the fabled planet 9 is herding these distant worlds into alignment. Picture a shepherd guiding sheep. The unseen planet's gravity would nudge objects like TG387 into similar orbital orientations, keeping them grouped despite the staggering distances between them. Every time astronomers discover another of these far-flung objects with peculiar tilted orbits, the case for Planet 9 grows stronger, and the Goblin's path is one of the most persuasive clues yet. What's wild is how little we actually see of this dwarf planet's marathon orbit. Its discovery came during a brief window when it ventured close enough to the inner solar system, still twice as far as Pluto to be spotted by telescopes. For most of its 40 millennia loop, it vanishes into the void, too faint and far-flung to detect. Even at its closest approach, sunlight takes nearly 11 hours to reach its frozen surface, where temperatures hover just a few degrees above absolute zero. This isn't just a cold world, it's a time capsule, preserved nearly untouched since the solar system's birth, its chemistry possibly holding secrets about how planets form in the harshest environments. The hunt for the Goblin's hypothetical puppeteer, Planet 9, is one of astronomy's greatest treasure hunts. Theorists calculate it could be 5 to 10 times Earth's mass, tracing an orbit so vast it might take 10 to 20,000 years to circle the Sun. But finding it, that's like searching for a black marble in a coal mine using only a flickering candle. Telescopes have to scan vast swaths of sky, looking for the slowest moving pinpricks of light, a task complicated by the fact that no one knows exactly where to point. Every oddball object like the Goblin helps narrow the search, its path acting like a cosmic arrow pointing toward where the unseen giant might lurk. Yet the Goblin isn't just a clue, it's a paradox. Its very existence challenges our models of solar system formation. How could something so small survive in such a stretched orbit for billions of years without being flung into interstellar space? The answer might lie in a delicate gravitational ballet, where distant giants like Planet 9 stabilize these far-out worlds, their influence creating pockets of surprising order in the Kuiper Belt's chaotic fringe. Or perhaps the Goblin is an interloper captured from another star during the Sun's infancy, now trapped in an orbit that defies local logic. For now, TG387 remains both a Rosetta Stone and a riddle, a frozen sentinel at the solar system's edge, whispering tantalizing hints about forces we've yet to see. Every new observation peels back another layer, inching us closer to answering one of astronomy's most gripping questions: what else is hiding in the dark? The Goblin's elongated path isn't just a curiosity, it's a trail of breadcrumbs leading us deeper into the unknown. Some cosmic explosions announce themselves with a bang and fade quietly, but not the Tasmanian Devil. This relentless burst of energy, officially known as a 2018 cow, doesn't just explode once. It erupts over and over, firing off violent flares that outshine entire galaxies, each blast packing the energy of 100 supernovae. And here's the kicker: no one knows exactly what's powering it. When astronomers first spotted this phenomenon in 2018, they assumed it was a typical supernova. Then, like clockwork, the flares kept coming, dozens of eruptions in just a few months, each one unleashing more energy than our Sun will produce in its entire lifetime. The behavior was so bizarre, researchers nicknamed it the Tasmanian Devil, a nod to its frenzied, unstoppable outbursts. Unlike anything seen before, this thing defies the usual death throes of stars. So what's behind the chaos? One leading suspect is a magnetar, a neutron star with a magnetic field so strong it could strip the data from every credit card on Earth from halfway across the galaxy. Normally, magnetars flare when their twisted magnetic fields snap and realign, releasing stored energy like a cosmic rubber band. But the Tasmanian Devil's bursts are too frequent, too violent to fit that mold. Some scientists think we might be witnessing a star that almost became a supernova, collapsing into a magnetar but somehow failing to fully detonate. Imagine a bomb that doesn't explode all at once, just keeps fizzling in catastrophic, repeated bursts. Then there's the black hole angle. Could these eruptions be the death spasms of a star torn apart by a black hole's gravity? Tidal disruption events where stars are shredded by black holes can produce intense flares, but they usually fade after weeks. The Tasmanian Devil lingers, flaring unpredictably like a malfunctioning cosmic strobe light. The most unsettling part, we still don't know its exact location. Buried in a faint, distant galaxy, the bursts arrive at Earth bright enough to study, yet their origin remains frustratingly obscured. Each new flare is a clue, but the Devil plays tricks, sometimes vanishing for weeks, only to roar back without warning. One thing's certain, whatever's happening out there is rewriting the rules of stellar explosions. The Tasmanian Devil isn't just an oddity, it's a challenge, forcing us to rethink what stars are capable of in their final, furious moments. Across 13 billion light-years of space and time, a ghostly giant defies explanation. Himiko, the space blob. This colossal cloud of primordial gas, named after a legendary Japanese queen, stretches 55,000 light-years wide, nearly half the diameter of our Milky Way. Yet it hails from an era when the universe was just 800 million years old. That's barely a toddler in cosmic terms, a time when the first galaxies were still taking shape. What makes Himiko so baffling isn't just its size, but its existence at all. In the early universe, structures this massive shouldn't have had time to form. Yet there it glows, a luminous enigma challenging our understanding of cosmic dawn. Most early galaxies from this epoch are faint, compact things, tiny seeds of stars huddled in the dark. Himiko is the opposite, a sprawling, glowing monster radiating the energy of 40 billion suns. Its light, stretched by the expanding universe into infrared whispers, reveals a cocktail of hydrogen and helium virtually untouched by heavier elements. This is raw cosmic material, the pristine fuel that would one day forge planets and life. But how did it clump together so quickly? Current models of galaxy formation rely on dark matter's gravitational scaffolding to slowly pull gas into denser pockets over billions of years. Himiko's sheer scale suggests something accelerated that process, or that our models are missing a crucial piece of the puzzle. One leading theory involves cosmic tsunamis, shockwaves from the explosions of the very first stars, which could have compressed gas into vast, glowing blankets like Himiko. Another idea posits that multiple protogalaxies collided in a frenzy of early growth, their mergers igniting furious bursts of star formation. Then there's the dark matter wildcard. What if the invisible web of the early universe had denser nodes than we thought, regions where gravity worked overtime to assemble giants in record time? But Himiko guards its secrets well. Follow-up observations revealed 3 distinct bright regions within its haze, not one unified structure, but possibly a trio of galaxies in the act of merging. This would make it a snapshot of cosmic construction, a rare glimpse of how the universe built its first titans, yet even that explanation feels incomplete. If Himiko is a galactic pile-up, why does its light appear so smooth, lacking the violent distortions typical of collisions? The most tantalizing clue lies in Himiko's light signature. Unlike later galaxies enriched by generations of supernova, its spectrum shows almost no heavy elements, just the bare bones of hydrogen and helium forged in the Big Bang. It's a living fossil, a relic of the universe's rawest building blocks. That purity suggests we might be seeing one of the very first structures to emerge from the cosmic dark ages, a time before stars had fully lit up the cosmos. Yet for all its mystery, Himiko's legacy is clear. It forces us to rethink how quickly the universe woke up. If giants like this existed so early, the first galaxies didn't just grow slowly, they exploded onto the scene, rewriting the rules of cosmic evolution. Every new observation peels back another layer, revealing an early universe far more dynamic and unpredictable than we ever imagined. And somewhere in that primordial glow, the answers to our deepest questions might still be waiting, frozen in starlight from the dawn of time. Floating in the void like a spectral smudge of glowing green, Hani's voorwerp is the universe's most haunting cold case. Discovered in 2007 by Dutch schoolteacher Hani van Arkel, an amateur sifting through Galaxy Zoo project images, this bizarre blob defies all expectations. At first glance, it looks like a cosmic spill, an ethereal wisp stretching 30,000 light-years across. But this is no ordinary nebula. Its eerie emerald glow comes from ionized oxygen, a sign it's been blasted by radiation so intense it should have dissolved eons ago. The twist, the quasar that likely lit it up has been dead for at least 100,000 years. This makes Hani's voorwerp a celestial fossil, a light echo frozen in time. Imagine shining a flashlight at a distant wall, then turning it off. For a split second, the wall still glows, catching the last photons racing toward it. That's what's happening here, but on a galactic scale. The voorwerp's green fury is the afterimage of a quasar's final roar, a beam of ultraviolet fury that left its source long before human civilization began. The quasar, nestled in the neighboring galaxy IC 2497, has since gone dormant, its black hole engine running out of fuel. Yet its ghostly echo lingers, a testament to violence we missed by cosmic microseconds. But the mystery deepens. When astronomers measured the voorwerp's light, they found something impossible. It's still being ionized, as if some unseen force is keeping it charged. The dead quasar shouldn't have enough juice to power this glow, so what's the secret? One theory suggests the quasar didn't just fade, it flickered, surging back to life intermittently like a dying light bulb's last sparks. Another proposes that IC 2497 black hole isn't entirely dormant. It might be leaking just enough radiation to keep the voorwerp simmering. Or perhaps there's an entirely new class of invisible energy sources at work, something our telescopes can't yet detect. Then there's the voorwerp structure, a tattered, uneven cloud with filaments stretching like cosmic cobwebs. These wisps are actually tidal tails, remnants of a galactic near miss where IC 2497 grazed another galaxy, sending shockwaves through the surrounding gas. That collision might have funneled material toward the black hole, briefly awakening the quasar and lighting the voorwerp's fuse. Now, like a neon sign flickering in an abandoned building, it glows alone, its power source vanished but its echo refusing to fade. What makes Hani's voorwerp truly special isn't just its eerie beauty, it's the questions it forces us to confront. How many other ghostly echoes lurk in the darkness, relics of quasars we didn't witness in their prime? And what does it mean that some cosmic events leave signatures lasting far longer than their triggers? For amateur astronomer Hani van Arkel, spotting this anomaly was a stroke of luck. For science, it's a window into the universe's hidden rhythms, where even death can't silence the echoes of the past. Two cosmic titans slammed together in a slow-motion collision of unimaginable scale. The El Gordo Galaxy Cluster, officially known as ACDCLJ 0102-49151. 7 billion light-years away, this gargantuan structure tips the scales at 3 quadrillion times the mass of our Sun, making it the largest known galaxy cluster in the early universe. But its record-breaking heft isn't even the strangest part. Peel back the layers and you'll find a celestial battlefield where dark matter, superheated gas, and entire galaxies have been torn apart and rearranged by gravitational forces beyond comprehension. Start with a bullet of scorching plasma, a shockwave of gas ripped from one of the colliding clusters, now streaking through the void at millions of miles per hour. X-ray telescopes reveal this structure as a glowing arc, hotter than the surface of the sun, where particles are accelerated to near light speed by the violence of the impact. It's like watching a shotgun blast frozen in time, the spray of galactic debris stretching across space. But here's what makes it bizarre: the gas isn't where it should be. During the collision, friction caused most of the visible matter to lag behind, while the dark matter, unaffected by such forces, plowed ahead like a phantom freight train. The result, a cosmic mirage where the cluster's gravity, mapped through light-bending effects, appears separated from its glowing gas by over 5 million light-years. Now picture the chaos behind this split. Simulations suggest El Gordo began as two smaller clusters, each already thousands of galaxies strong, barreling toward each other at over 4 million miles per hour. As they merged, their combined dark matter halos created a gravitational lens so powerful, it distorts the light of even more distant galaxies into surreal arcs and smears. This lensing effect is our key to mapping the invisible. By studying how background starlight bends around El Gordo, astronomers can trace the hidden skeleton of dark matter holding the entire structure together. Yet the biggest shock lies in its very existence. At 7 billion light-years away, we're seeing El Gordo as it was when the universe was half its current age. According to conventional models, clusters this massive shouldn't have had time to form so early. Some theories propose dark energy, the mysterious force accelerating cosmic expansion, might have played a role, its repulsive gravity ironically helping matter clump faster in certain regions. Others speculate El Gordo could be rarer than a winning lottery ticket, a fluke of cosmic overdensity we're lucky to catch in the act. One thing's certain, this collision is far from over. The galaxies themselves, spaced so widely that direct impacts are rare, will eventually settle into a new equilibrium. But the gas, it's still sloshing, its turbulent motions detectable in subtle X-ray fluctuations. And the dark matter, it's already moved on, an invisible architect reshaping the universe while we piece together its blueprints from the wreckage left behind. El Gordo isn't just a cluster, it's a time capsule from an era when the cosmos built its largest structures in fire and shadow. A reminder that even the biggest things in the universe are born from chaos. Deep within the swirling chaos of star-forming regions, where temperatures plunge to near absolute zero and gas coalesces into newborn suns, astronomers have uncovered something unexpected, a cosmic confectionery. Floating among the frigid clouds are vast reservoirs of glycolaldehyde, a simple sugar molecule that happens to be one of the key building blocks of RNA. That's right, the universe isn't just forging stars and planets, it's brewing candy. These sugar clouds weren't found with a telescope's lens but with its ears. Radio observatories like ALMA in Chile detect the faint whispers of molecules vibrating in space, each chemical compound singing its own unique frequency. When scientists tuned into the frequencies of glycolaldehyde, entire stellar nurseries lit up with its signature. In places like the Rho-Ophiuchi cloud complex, just 400 light-years away, sugary molecules swirl by the trillions, clinging to dust grains like frost on a windowpane. What makes this discovery revolutionary isn't just the sugar itself, it's the implications. Glycolaldehyde is a precursor to ribose, the backbone of RNA, which means these clouds could be stocking the pantry for life's earliest recipes. Imagine a drifting molecular factory where simple sugars link up with phosphates and nitrogenous bases over millennia, eventually forming the complex molecules that kickstart biology. The fact that we're detecting this stuff in the same regions where planets form suggests a mind-bending possibility. The ingredients for life might be baked into the universe's star-making process from the very beginning. Yet the real surprise is how common these sugar clouds seem to be. They've been spotted near protostars in comet tails, even in the frigid gaps between stars. If glycolaldehyde is this widespread, it raises the odds that life's molecular toolkit isn't some rare cosmic accident. It's practically a default setting, scattered across the galaxy like edible stardust. Still, mysteries linger. How do these delicate sugars survive the violent radiation and turbulence of star birth? Some theories suggest icy dust grains act as shields, sheltering the molecules long enough to hitch rides on comets or asteroids. Others propose that glycocalyx compounds form naturally in the freezing voids, assembling piece by piece like a slow-motion jigsaw puzzle. One thing's certain, every time we point our telescopes at these starry kitchens, we're not just watching worlds form, we're glimpsing the universe's sweet tooth at work. And if sugar is already floating in the void, waiting to be scooped up by newborn planets, what other treats might be hiding in the cosmic pantry? We know the pillars of creation, those towering spires of dust and gas immortalized by Hubble, where newborn stars gleam like gems in a cosmic cathedral. But deep in the Carina Nebula, a darker counterpart lurks, the pillars of destruction. These twisted columns aren't nurturing stars, they're being erased by them, their very substance blasted away by the relentless fury of young, massive suns. Where the pillars of creation represent birth, these structures showcase the universe's brutal balance. For every act of creation, there's an equal and opposite force of annihilation. At first glance, the pillars of destruction mirror their famous cousins, three light-year-tall tendrils of cold molecular gas, backlit by the glow of ionized hydrogen. But zoom in, and the differences become terrifyingly clear. Radiation from nearby O-type stars, some 50 times more massive than our Sun, is cooking these pillars from the outside in. Ultraviolet photons strike like battering rams, stripping electrons from atoms and sending shockwaves rippling through the gas. Time-lapse simulations reveal the carnage in gruesome detail. Over mere thousands of years, a blink in cosmic time. The pillars distort, fray, and eventually dissipate, their material evaporating into the nebula like smoke in a hurricane. What makes this process so stark is the fate of the stars inside these pillars. Normally, stellar embryos nestled in dense gas clouds are protected, cocooned until they're ready to ignite. Here, the radiation is so intense it's sandblasting these protostars bare, stealing their natal material before they can fully form. Some might never grow beyond failed embers, their potential snuffed out by the very environment that birthed them. Others, ironically, get a violent kickstart. The surrounding gas, compressed by the radiation's pressure, collapses faster, sparking premature fusion. It's stellar evolution in overdrive, where the rules of gentle accretion are rewritten by chaos. And then there's the invisible wreckage. As the pillars disintegrate, they leave behind trails of ionized gas, chemical fingerprints of their destruction. These are more than just cosmic scars, they're recycling centers. The obliterated material, rich with carbon and silicates, gets swept into the nebula's currents, eventually coalescing into new generations of stars and planets. The pillars of destruction aren't just a demolition site, they're a forge where the ashes of one structure become the bricks of the next. Yet the most haunting lesson here is one of perspective. The pillars of creation, for all their fame, are likely already gone. By the time their light reached Hubble, they'd probably been vaporized by a supernova shockwave. We're just seeing their ghost. The pillars of destruction, meanwhile, are a real-time execution, a reminder that the cosmos doesn't play favorites. Beauty and violence aren't opposites. They're two sides of the same celestial coin, spinning endlessly in the dark. Hidden among the vast catalogues of galaxies, astronomers found something bafflingly small yet dazzlingly bright, the so-called green pea galaxies. These tiny cosmic anomalies, barely a tenth the size of the Milky Way, glow with an eerie emerald hue, their light dominated by intense bursts of ionized oxygen. Discovered accidentally in 2009 by citizen scientists scouring Galaxy Zoo project images, these peculiar objects shouldn't exist under traditional galactic models. Yet here they are, flickering like cosmic fireflies in the darkness of the early universe, rewriting our understanding of how small galaxies can shape the cosmos. What makes green peas so extraordinary isn't just their petite size or peculiar color, it's their ferocious energy. Pound for pound, these galaxies churn out new stars at rates that dwarf even the busiest stellar factories in larger galaxies. Imagine a cottage producing the industrial output of a metropolis. That's the level of overachievement we're dealing with. In some cases, green peas form stars 10 times faster than the Milky Way, despite being hundreds of times smaller. This hyperactivity floods their surroundings with ultraviolet radiation, enough to strip electrons from atoms in a process called ionization. And that's where these tiny powerhouses punch far above their weight. Scientists now suspect green peas might be local analogues to the distant, faint galaxies that drove one of the universe's most pivotal events, the epoch of reionization. Billions of years ago, when the cosmos was just a fog of neutral hydrogen, something ripped those atoms apart, rendering the universe transparent to light for the first time. For decades, theorists struggled to explain how until they studied these unassuming green specks. The radiation from green peas is so intense, it could serve as a miniature blueprint for how early dwarf galaxies flooded the cosmos with enough energy to lift the primordial veil. Yet mysteries cling to these emerald oddballs. Why are they so rare in the present-day universe? Most green peas are time capsules, relics from billions of years ago, their light only now reaching us. Modern galaxies of similar size lack their explosive vigor, hinting that the conditions fostering such extreme star formation, perhaps richer gas reservoirs or fewer galactic predators, have vanished with time. Even stranger is their peculiar chemistry. Green peas are oxygen factories, their spectra revealing abundances of this element far higher than expected for their youthful starbursts. Normally, oxygen builds up gradually over generations of stars living and dying. The peas' excess suggests their star formation is not just rapid but peculiarly efficient, like cosmic alchemists turning hydrogen into heavier elements at breakneck speed. These galaxies may be small, but their implications loom large. They challenge the assumption that only massive galaxies shape the early universe, proving that sometimes the tiniest players wield the most transformative power. In their emerald glow, we might finally be seeing the unsung heroes of cosmic dawn, the little engines that lit up the darkness. At the outermost edge of our solar system, where sunlight dwindles to a faint whisper and the pull of distant stars begins to rival the sun's weakening grip, a lonely wanderer traces an orbit so vast it redefines the boundaries of our cosmic backyard. Meet Far, Far Out, a provisional name that belies its significance, currently holding the title as the most distant known object in our solar system, drifting a staggering 132 astronomical units from Earth. That's over 12 billion miles away, 4 times farther than Pluto, so remote its journey around the Sun might take a millennium to complete. Discovered in 2018 during a hunt for the hypothetical planet 9, Far, Far Out isn't just notable for its distance, it's a puzzle wrapped in ice. Preliminary observations suggest it's likely a chunk of rock and frozen volatiles, perhaps 300 miles wide, though its exact composition remains a mystery. Unlike closer Kuiper belt objects, which still feel the sun's warmth enough to occasionally sprout fleeting atmospheres, Far, Far Out exists in a perpetual deep freeze. Temperatures here hover just a few degrees above absolute zero, cold enough that even nitrogen and methane freeze solid, coating its surface in an ancient, untouched crust. But what truly fascinates astronomers isn't just where Far, Far Out is. it's how it got there. Objects don't naturally settle into such stretched orbits unless something nudges them. The leading theory, gravitational interactions with Neptune billions of years ago, might have flung it outward like a cosmic slingshot. Yet some researchers wonder if subtler forces are at play. Could the gentle tugs of as yet undetected Oort cloud objects, or even the hypothetical planet 9, be subtly herding far, far out and its kin into these bizarre, elongated paths? Every slight wobble in its trajectory, every deviation from predictions, could be a clue pointing to unseen masses lurking in the dark. Then there's the question of kinship. Far, far out isn't alone in its remoteness. It joins a growing list of extreme trans-Neptunian objects far out, Goblin, Sedna, all tracing peculiar orbits that cluster in ways that defy random chance. These distant bodies might be the first breadcrumbs leading us to a deeper truth about our solar system's architecture. Some simulations suggest they're the survivors of a chaotic era when the giant planets migrated, scattering debris into the void. Others posit they're captured interstellar interlopers, snatched from passing star systems during the sun's infancy. For now, far, far out remains a faint blip in telescope data, its full story still out of reach. Upcoming observations with next-generation instruments like the Vera Rubin Observatory could reveal its surface composition, rotation rate, and whether it has companions details that might crack open the secrets of the solar system's twilight zone. Until then, it stands as a sentinel at the frontier, a reminder that even in our own celestial neighborhood, the most ordinary-looking specks of light can hold extraordinary tales of gravity, chaos, and the invisible hands shaping our cosmic home. From stars that spin faster than kitchen blenders to ghostly radio circles wider than galaxies, the Milky Way is jam-packed with cosmic oddities that defy logic. We've wandered through black holes that fling stars like slingshots, diamond planets forged in stellar collisions, and sugar clouds sweetening the void, proof that our galaxy isn't just a collection of stars, but a stage for physics' wildest experiments. Every one of these 30 objects challenges what we thought possible. Pulsars that devour their neighbors, galaxies shaped like perfect smoke rings, and dark matter halos holding everything together without ever showing their face. What binds these enigmas together? They're all cosmic boundary pushers, phenomena that force scientists to scribble new equations or toss old textbooks aside. Take the Great Attractor, an invisible force dragging galaxies toward it while hiding most of its mass, or the old smoker stars puffing out organic molecules like interstellar bakers. These aren't just quirks, they're clues, each one a piece of a puzzle we're still assembling. The Milky Way doesn't play by our rules, it invents its own, leaving astronomers scrambling to catch up. And here's the thrilling part, we've only scratched the surface. For every mystery solved, 10 more emerge from the cosmic shadows. The universe doesn't owe us answers, it rewards curiosity with even deeper questions. So keep looking up, wondering what else lurks in those glittering spiral arms. Who knows, the next time you gaze at the Milky Way's faint band of light, you might spot the glow of something stranger than we've ever imagined. If these cosmic wonders blew your mind, there's plenty more where they came from. Hit like, subscribe, and ring the bell. Our next adventure into the universe's weirdest corners is already brewing. Until then, stay starstruck. The galaxy's greatest mysteries are still waiting.